All right, okay, so we're gonna start with a request to talk about documentation and some like tips and tricks for, breaking down documentation, because documentation is definitely something that is going to be very important, because not every library you are going to be using will actually have a, as you know, we don't go very in depth about all of the functionality of every library, and very likely in the future, you're going to find a library that you want to use, and the only way you're going to figure it out is by reading documentation or by looking at examples. Some documentation is actually very helpful. I personally quite like Seaborn's documentation because it's very example heavy. But there are others like Matplotlib that are a little harder to break down. So some of the main elements of documentation, every method I believe for pretty much every library I've ever come across, every method usually has its own page or section, which actually tells you how to use the specific method. So the structure for different documentation is very, very similar. They always have this like parameters section as well as what it returns. So this is one of the more complicated ones, I think, subplots. So subplots actually take in all of these arguments. Another thing that actually Ali brought up was, what is KW args? I think it must say somewhere here. Basically, you might see the word kwargs, which is KW args, which actually stands for keyword arguments. And that basically means that it can take in arguments from other things, which for different methods, it could mean different things. But in this case, as you see here, it says like fig KW means that it can take in keywords from the figure method as well, which for this is a little confusing. But let me talk about like the overview of a general documentation page first. So first you usually have like this written up. I think in this library it's like this. I think like most pandas, let me just pull up a random one. So here in pandas like 2CSV, they give you exactly like how you would use it. One main thing it shows you is like, all right, what do you use the method on? So here you can see that this is actually, all right, this is just used out of the pyplots, because as you remember, we actually import matplotlib.pyplot as PLT, which is why when we're using subplots, we actually use PLT.subplots. So that's like one part to remember what you're using the method on. I think actually this is more relevant for pandas, because pandas, sometimes you do PD dot something and sometimes it's DF dot something. So here, because data frame is like, the data structure that we're using, the 2CSV method works on data frames, which is why here you can see it says data frame dot 2CSV. In contrast, something like, I think read CSV, if we see read CSV, it says pandas.read CSV. So the differences here is that read CSV comes straight from pandas, which is why we do pd.read CSV. And then here with 2CSV, it's straight away data frame.2CSV. So 2CSV actually acts on a data frame. That's the first part, just knowing what the method acts on. And then what the method acts on, and then you have all these parameters that the method takes in. A lot of them are explained. Like, for example, here you can see, like, all right, the path of the CSV you want. Are there any like separators? This basically means that 2CSV, you can actually save it as instead of comma separated values, you can do it with something else. I think the other more common one is tab separated values. If any of you have seen TSVs, TSVs is, I think, a few of the data files in the first project are TSV files, if I remember correctly. So all of these are parameters that you can feed into your method. What they have here, the ones that they actually put here, because you can see they're actually defining all the parameters here. These are the default parameters. So they have default parameters such that every time you use a method, you don't have to feed it in all of these. Because, for example, if you were to define a function that takes in 2 arguments, but you only give 1, it'll say that, wrong number of arguments. Having these default arguments here makes it such that, you know, whichever argument that you do want to change that's different from the default, you only have to put in those. So for toCSV, pretty much we only put the path, and everything else will actually use these default arguments, which is why when we do toCSV, we don't have to define all of these arguments in our method. So that's about arguments. Sometimes, and back to what I was talking about with keywords, I think matplotlib is a very common one that uses it. Here you can see star star keywords. Anytime you see something with star star, means that it can take an infinite number of these figure keywords. This is more specific to matplotlib, but basically this star star fig keywords, or in other documentation, if there's something similar, it might show up as kwargs, like KWARGs, keyword arguments, which basically means you can actually feed it in any number of other keywords. And in this case, in this documentation, it actually says for, all right, fig KW, if we go down, you can say that you can use any of the other keyword arguments that are also used in the pyplot.figure call. So that means, you know, for these subplots, you can give it all of this, but if you want to define additional things, you can define anything that is also from here. And you can see that, yeah, this is another example. Within the dot figure, one of the last arguments is actually kwargs, keyword arguments. And therefore, from here, if you see figure, these are all the additional arguments that you can feed it in. Questions about that so far? All right, so that's parameters. Another big part about documentation is the returns. So for different methods, they return different things. Like for example, here, the toCSV, it doesn't return anything unless you, I think, yeah, unless you give it none, then it'll return you the CSV format as a string. I think another one that they talk about is here, in the subplots documentation, you actually get two things returned. You get your figure and your axes. And that's basically why we have this like fig comma ax equals to subplots, because this actually returns two separate things. So that's another thing that documentation will tell you. Let me see if I can find like a different pandas one. Let's say we look at pandas. Let's use pandas. Let's see. Let's take one of these here. Let's do apply and see what that does. So you can see dot apply, it takes in the function, which I think more commonly we've been using lambdas for dot apply. You can feed in all of these arguments. And here it returns a series or a data frame, which is, as it says here, a result of applying the function. So basically through reading documentation, you know what the method is, what it works on, what parameters you can give in, that you can give it, as well as, you know, what it returns. So yeah, that's kind of an overview of documentation. Pretty much any library that you use will have this similar format. I think the next big library that we will be using is stats models. So for example, stats models, let's take a look at this one. I don't know if this one will make much sense. But here, this is one that we're actually going to use next phase. Basically, we are going to be doing linear regressions. And here you can tell it, all right, what are the variables that we're giving it, any extra models here, some examples. Let's see, where is the return section? Here you can see that it returns, I guess not here, but let me take a quick look. It's been a while since I looked at this, but right here, and this will make much more sense next time. On this OLS method, you can actually use more methods on top of that. And we'll talk about the next mod. I feel like I shouldn't have brought this up because now it looks confusing. But anyways, once you have this, this actually does include other things. Like for example, here you can actually use methods on top of this one. And yeah, documentation will show you of that. So yeah, I think that's like my overview of documentation. It does take a bit of getting used to. I think the one that's most common is probably something like, I think as an example, like Seaborn's documentation, right? Seaborn's documentation, because we have different kinds of plotting. Like for example, there's dist plot, there's dist plot without the T, there's also hist plot. They all take slightly different parameters. So going through, you know, the parameters for that will basically tell you the differences between how you use the 3 different methods. But yeah, anything else about documentation? Anything that, I don't know, that I could help clarify?
I think Ali specifically mentioned self being one of the parameters.
Yeah, that's a really good question. So self actually comes back to, yeah, thanks for reminding me, Melody. Self comes back to object-oriented programming, which is something that we're only going to talk about towards the end of phase 3. I don't know which one specifically has the self. Does anyone know which documentation by chance has like the self argument? Maybe it is figure, maybe. So basically self, you don't have to give it, you don't have to define self. Self basically is, oh, here we go. Yeah, so let's see, this is figure. All right. So in this .init function that you can actually use on a figure, whenever you see self, it's basically that this function acts on a figure object. If that doesn't make sense, we will actually have an entire topic that we're going to talk about what these really mean. But every time you see self, self is, you can sort of think of it as like an attribute of whatever object it's working on. So for example, here, if it's get state self, I don't know what get state is, but get state would just be an attribute of the figure object. So I'm looking at the figure documentation here. Self is just, whenever you see a self argument, one, you don't have to give it, you don't actually have to say like self equals to whatever. It automatically knows because of the way object-oriented programming works. And we will talk about that in actually like a couple months. But also it's usually attributes of the object. And this, in this case, the object is the figure that you're instantiating. I don't know if I said like just a bunch more words that made things more confusing. But yeah, so here, as you can see, self is given here. You don't actually have to use self, but yeah, I don't really know how to explain it, but hopefully it helps a little bit to know that you don't ever have to give it the self argument. When it comes to object-oriented programming and the way that we're going to go through it, we're actually going to learn how to write. Your own classes of functions and methods, and then that's how you'll sort of see how we use self. So as you can see, I think not all of them do, but some of the documentation is written in a class. Yeah, so for example, this stats models one, it says it's in a class. This, not this one, but where's the matplotlib one? The matplotlib documentation, they're all in classes. So we'll be learning actually how to write classes of functions that you can then import and use in your project. So for example, you know, you might want to write like your own set of functions for data cleaning that you can then just import into your notebook and use, rather than, you know, defining it in your notebook. So we'll actually only talk about that in phase 3, but hopefully this helps a little bit. I don't know if anyone needs to clarify anything, let me know, but it's kind of hard to explain things because I will have to use like a lot of terms that we haven't talked about yet. But yeah, I think the main takeaway here is just get used to the documentation and like different parts of documentation. And also self is something that we don't have to worry about for now. Cool. Before I move on, any other thoughts about documentation? Cool. All right. Because I wanted to talk about updating the Learn environment. So let me just reshare my screen because we're going to need to see my terminal for this. All right. So here you can see my terminal, and I'm in the Learn environment. Basically, why we want to do this is there are certain, I think for this project specifically, I've actually had quite a few students bring up some functions not working. So for example, these two, if anyone has tried and is working off of the Learn environment, this plot and his plot actually don't exist in the Learn environment version of Seaborn. So if you've been trying to use these functions and they don't work, it's because the Learn environment has a slightly outdated version of Seaborn, and these are new. As you can see, the one that is in our version is dist plot, so dist with a T, whereas this one has no T. This one you can see that it's actually deprecated and will be removed in the future. It's one of the downsides to having a Learn environment is that, you know, every time something new comes up, we actually have to update it. But we can talk about how to update that. So basically, if you're running into issues where dist plot or his plot isn't working, use dist plot for now or update your Learn environment. I'm going to walk through that process really quickly. So with our Learn environment, as you can see here, I have it activated. One thing you can do is to check. So here we're dealing with Seaborn. One thing you can do is actually check the version of your Seaborn just to make sure that you have, just to check if you do need to update it or not. You can do this in your Jupyter notebook, or you can do this here. And what I did here was actually launch Python in my terminal, and Git bash works exactly the same. If you want to launch Python, just type in Python. And here it doesn't work exactly like a Jupyter notebook, but you can do things like import Seaborn as SNS. Let's see what happens. I think it's importing, so let's wait a little bit. All right, so Seaborn has been imported. One thing you can do to check the version is you type the name of the package. Let me make this a bit bigger so we can all see. You do SNS dot dunder, and dunder is short for double underscore, dunder version. So it's 2 underscores on each side. When you run that, you can see that I actually have Seaborn version 0.9.0. And the version that is out is actually 0.11.0. So I'm quite a few versions behind. And how we update that is actually through updating our environment.yaml file. So let me exit out of Python. And to exit out of your terminal's Python, you just type exit with the parentheses. So what we want to do is actually change our environment file. Because I forgot where I had cloned my environment file, I'm just going to re-clone the environment file from GitHub, and that's on your lesson of setting up your data science environment. Hopefully you remember where yours is. I don't remember where mine is, so I'm just going to quickly just git clone that. Oops. Thanks. There we go. So I've git cloned my environment file, and then what I'm going to do is I'm going to cd into that. There we go. And so the thing that we're going to edit is, as you can see here, if you are on a Windows computer, you're going to be editing this file. And if you're on a Mac computer, you're going to be editing this file. Both of them have almost the same stuff. The dependencies that are different in each one shouldn't be affected by any particular, it shouldn't be affected by any of the things that we're going to update. So how do we update the environment.yaml file? Basically, the idea of what we're going to do is we have this environment that has these slightly outdated packages, and the way to update, you know, which version of the package that we want, we're actually going to delete the environment and then reinstall the new environment. So to do that, let's see. First, we want to open up our environment file. So depending on what your operating system is, if you are on on a Mac, you're going to open up environment.yaml. If you're in a Windows, windows.yaml. So to this, I'm just going to do open environment.yaml. Open that. This actually opens in my default text editor. I think if you don't have a text editor, it will open in like Notepad or I think the Apple text editor. And what you want to do is just look for the package that you want to update. And here you can see Seaborn. Here I have 0.10.0.10.0. I think the version that I had was an even older version of Learn environment, and just edit it to the newest version. So I know that the newest version based on documentation is 0.11.0. I'm just going to go in here and, oops, where'd it go? There we go. And just change the version, save it, and that's all good. So if you've ever looked into your environment.yaml file or your windows.yaml file, it's literally all the packages that will be installed when you create the environment. So that's here. Several things that you can do. If you want to be a little bit safe, you can just create a brand new environment, call it like Learn-env2 or something. But what I'm going to do, I'm just going to delete my Learn environment and then recreate it. So let me actually pull up some instructors for myself because I don't remember them off the top of my head either. Let's clear this. So first we are going to have to deactivate the current Learn environment that we're in. And to do that is just conda deactivate. Once you've done that, the Learn environment, and for different terminals and different Git bashes, it will look slightly different, but it will be back to your base. The Learn environment will not be there. And then we're actually going to delete the Learn environment. I'm going to delete the Learn environment. You can choose to actually just create a new Learn environment. So here, we can do a conda env remove -n learn env. If you ever need like these instructions, just Slack me and I can send you these instructions. And so then when I run this, it's going to ask me if I want to delete all of the files. So it's going to remove all the packages. Yes, which is what I want. I think I give it yes. Let's wait for it. I think my computer is a little bit laggy right now. Never mind. Let's do this again. We're going to remove the Learn environment. I'm going to be more patient this time. All right, and so Learn environment should be removed. And now what I can do is I can just create my new environment. And what I'm going to do is I'm going to do conda env, and I think this code can be found right here in your setting up. I'm actually just going to copy and paste it from here. Setting up your environment, I'm going to do here, conda env create environment.yaml. So let's just get rid of this, paste this. And it's just going to install all the packages with the versions that I have asked it to do. And then same process as what you were doing when you were setting up. It should work. But yeah, any questions about this part so far? Basically in the future, if you ever want to like get an updated version of any package, you can edit it this way. Yeah. It does take a while. Great. Things are happening. It might take a while because they're downloading like quite a few packages.
So is there not a way to just update one package? You have to redo the whole environment?
That's the way that I know how to do it. I'm not too sure about single packages. This is just the way that I was taught by my instructors, to be honest. There probably is a way, but yeah, this is the way that I know how. I think it's also safer because this way, it also will double check the dependency of, for example, the new Seaborn and make sure that it's not missing any dependencies with any other package. So basically, like, let's say Seaborn 11 needs a particular level of matplotlib, and this will actually do that check as well. So slightly safer this way. If you were to just do the new Seaborn, for example, if you're not at a high enough level of matplotlib, it might lead to just Seaborn not working at all, and then you would just probably end up reverting it back to the old version. If that makes sense. But yeah, to be honest, like if you feel comfortable with like installing packages, you technically don't have to work in your Learn environment, and happy to talk about how not to do that. literally, if you don't want to work in your Learn environment anymore, like I personally don't work off the Learn environment just because I like to have, you know, the latest version of every package. You can just do conda deactivate so that you're out of your Learn environment. The only downside is every time you're using a new package, you would have to conda install it separately. So it's really up to you. Pros and cons of Learn environment. One pro is just like everything you'll need in this course. Well, almost everything you'll need in this course will already be pre-installed. But because of that, there will be some like outdated packages. But yeah, any other questions about this environment thing? Yeah, as you can see now, mine's all downloaded. I can now do conda activate Learn-env, and I can even launch a Jupyter notebook. Let's wait for it to launch, and we can just check the version of Seaborn. So for example, if I do a new notebook here, and if I import Seaborn as SNS, I hope that this works. We can check the version by doing SNS Thunder version. And on my computer, for some reason, the first time I run something, it just takes a long time. And there you can see my Seaborn has been updated. And I am in the Learn environment. I should be in the Learn environment. Let's double check. I think I am. And I think it should be fine because I know that my own version of Seaborn was not up to date either. But yeah, that's how you would update a package in your Learn environment. Let's see, any other questions? Cool. Yeah, basically, if you are trying to run like displot or hisplot, it's not in our version of Seaborn, so you would have to either do that or use displot. Now, all right, if there are no other questions about environment, I want to talk about project reviews because several people are nervous about that. For the project reviews, so typically project reviews are 45 minutes long, but I think for our class, we can do them 30 minutes because the 45 minutes usually includes the presentation. And because I like to actually have everyone present to each other, 30 minutes should be enough. So with the project reviews, you will schedule them in place of a one-on-one. So most of you that have recurring one-on-ones, I'm just going to assume that you're going to use your recurring one-on-one for a project review. And if you don't want that, just let me know. But each of you will actually schedule a project review with me individually. So it won't be in pairs. And yeah, roughly half an hour for each. And usually I am done with that under half an hour. So if you have questions about coursework or like one-on-one questions, you can ask them during that time as well. How I structure project reviews, because we have our presentations on Monday, I'll actually start with feedback on your presentation. And for the presentations, usually for the pair, you get the same feedback on the presentations, but no worries, I'll give the feedback to both of you as well. I will be taking notes on the presentation while you guys will be giving it, so you'll get that feedback during your project review. After the non-technical feedback, I'll basically ask you to walk through your notebook. And when I say walk through your notebook, I don't mean like talk about every single line of code. It's more about talk through like what your thought processes were. For example, if you have to fill in a bunch of null values, I'm not looking for, all right, I used the fill-na function to fill in these with the median. You really just have to say, I filled in null values with medians for maybe like column 1, 2, 3, or maybe columns 4, 5, 6 null values I dropped. Just a really quick overview. In terms of like your analyses, I'm really just looking for the process that you took to get from raw data to like a graph and an insight. So you don't have to go as in depth into your code as you think so. And if I want to get more details, I will ask. So yeah, I think a lot of people get really nervous because it's like a project review, and if you don't pass, you don't pass the phase, but it's actually quite chill. I'm not remembering if I'm forgetting any details, but does anyone have any questions about the project review process? Yeah, just remember it's in place of a one-on-one. I usually assume that it's like next week, like basically the first week, because yeah, basically you just have to get your project review done by, for this project, I believe it's November the 6th, which is next Friday. As long as you get your project review done by then, you should be fine. One thing I'm forgetting to mention is if during our project review, if there's something that isn't up to par or isn't up to standard to pass, you will have until November 6th to fix it. So for example, if there's like one graph that maybe you weren't able to plot, we can talk about it during the review, but you will basically like just send me like your notebook by November 6th, and I can just make sure that that is done, and then you're all good to go. But yeah, that's the project review process. Nothing too scary. But yeah, any questions about that? Or since I'm done with everything I wanted to talk about, any other questions regarding the project? Okay, going once, going twice. All right, well, since it's Friday, we're actually gonna dive into our feelings right now. So yeah, let me stop the recording and then stop share, and then we can get into that. Oh wait, let me see the chat before yeah, I'm gonna stop the screen share. Thanks, Tim. Stop.